Gradient descent in terms of linear algebra, the simplex method. Given a standard linear optimization problem in canonical form, put in slack variables to get rid of inequalities. Now our problem can be thought of as maximize this inner product subject to the system of equations. There's our basis. Or in linear algebra terms, our pivot variables. And we solve for the pivots. Starting at the origin, now I'm going to want x to enter, but I don't know if S1 or S2 leaves. S1 leaves or S2 leaves. I want S1 to leave. Or I want Y to enter. And I want S2 to leave. Set up the augmented matrix for AX equals B. Let's have X enter the basis. So the pivot is going to move to the first column, either the first row or the second row. Let's start with the first row. Solving for X. X is 3, S2 is 1/2. That's our solution that we got from last time. To solve for the second row, scale so that I have 1 as my coefficient. And I'm going to do this to every row. So every row has a 1. Then I subtract. Solving for X and S1. X is 4. S1 is -1. Not feasible. How to predict which row element to use without computing both? The answer is run the method, but only keep track of what happens on the right hand side. I normalize so that I have 1s in the column, keeping track of what happened to the right hand side after I do this operation. I want to pick the minimum ratio, because the next step is subtract. And I want the difference to remain a positive, so that my right-hand sides are positives, and my answer will be feasible. This is how I know what element leaves the basis. Is the minimum ratio. How did I know I want X to enter the basis? That's looking at the objective function. The elements of the objective function are the partial derivatives. I want the biggest partial derivative to take me uphill the fastest. So I want X to enter the basis. What we have just outlined is the simplex method. It is how you move from one corner to another corner of the domain. Step 1, pick the maximum entry in the C vector. Step 2, the minimum ratio of the right-hand sides over the column entries tells me what element will enter. And then step 3, I do the row reduction, setting up a larger augmented matrix. This is called the Simplex tableau. And let's run through the steps. We are our initial problem, so we're at the origin. I want one of these entries to leave the basis. X is going to enter the basis, and the first row is the element that enters. So S1 leaves. Do the row reduction. All the entries now in the C vector are negative. I'm at a maximum because these C values are my partials. Well, it's the same sign as my partials. They're both negative. I'm at a max. Remember from last time when we calculated our partials, partial derivatives leaving the corner were -5 and -3 over root 2.